All right, now we are going to look at nominal interest rates and effective interest rates. First of all, you must know the difference. All right, if you talk about effective interest rates, these ones, they have the same compounding period. I'm going to explain on this. Then, if you talk about nominal interest rates, they have different compounding periods. Okay, what do they mean? You remember the other time I gave you the table whereby you are given an interest which is compounded monthly. All right, for example, if someone say 15% per month, 15% per month, compounded half yearly. And then someone say 15% per annum, compounded yearly. All right, can you see? These are two compounding periods, per month, half yearly. So this one is nominal. It's nominal. So this is per month, this is per annum, compounded yearly. So this is effective. So that's the difference between effective interest rates and nominal effective rates. All right, but you are required to change nominal interest rate to effective interest rate. How do you do that? It's very easy. You use the following formula. 1 plus I effective is equal to 1 plus I nominal over m to the power of m, whereby m, these are compounding period. This is the compounding period. All right. For example, they can say convert 15% per annum compounded half yearly to an effective interest rate. How do you do that? You're just gonna say 1 plus I effective is equal to 1 plus I nominal over m. That's the formula. So first of all, it's 15% per annum. You see, it's per annum compounded half yearly. It's two different compounding periods. So in other words, it is this per annum compounded half yearly. It is nominal because it has got two different compounding periods. So you are supposed to change it to effective. So it's 1 plus I effective, which is equal to 1 plus 15%, it's 0.15 because it's 15 over 100, it is 0.15. It's compounded half yearly divided by 2, so to the power of 2. Then you make I effective is your subject of formula. 1 I effective is equal to 1 plus 0.15 over 2 to the power of 2 minus 1. Then you get the answer. Let me get the answer quickly. 1 plus effective, which is 0.15 over 2 to the power of 2 minus 1. Then you get I effective, you get 0.155265. If you convert this, you must change it to an effective interest rate. So this is not a rate, so if you change it to a rate, I rate, you're going to say 15.23%, because you're going to multiply this by 100 for you to get rate. All right. On the previous example, we're converting nominal to effective. Now we need to convert effective to nominal. Convert 17.38% interest, convert 17% per annum compounded yearly to an equivalent of this is effective nominal interest rate. So how do you do that? First of all, you're going to say, so you are given per annum compounded yearly, so it's nominal, so it's effective. Same compounding period, it's effective. So how do you convert it? You're going to use the formula 1 plus I effective, which is equal to 1 plus I nominal over n to the power of n. And then it's 1 plus your effective, it's 0.1738 is equal to 1 plus I nominal. Your nominal now is the one that you're looking for. Alright, we say that to an effective equivalent nominal interest rates, compound nominal interest rate per annum, compounded quarterly. So it's IN, then if it's compounded quarterly divided by 4, so it's 4 to the 4, it's to the power 4. Then we are looking for IN. So for you to get rid of this, you are supposed to say the fourth root of 1 plus 0.1738 is equal to 1 plus IN to the power over 4. This is the fourth root, but everything is to the power 4. Okay. Then if you say that, you are going to say 1 plus point then you're going to get 1,040874877 is equal to 1 plus I n over 4. Transpose the 1, you get 0,040874,877 is equal to I n to the power of 4. You multiply by 4. You get 0.1634995075. You're only allowed to change this. This is IN. Therefore IR, was you're looking for R. You are only allowed to round off to the nearest two decimal places. You only round off your final answer, not in between. So it's going to be 0.1634995,075 multiplied by 100. Therefore, your IR is 16.34%. Okay. All right, in this case, we are going to look at change of interest rate. Let's say, for example, you invest 10,000 in the money market, and for the first 4 years, your money it's accruing at 13% per annum. Then after 4 years, then there's change of interest rate from 13% maybe to 17%. How do you work it out? So I'm just going to write here change of interest rate, change of interest rate. And then when you change of interest rate, we are supposed to use timelines as well. All right, I'm going to give a scenario whereby for the first, maybe we're investing 10,000. Let's say you, or let's say maybe Paul. So Paul invested 10,000 into an account which pays 13% per annum, compounded half-yearly for the first 3 years, and then 16 or 17% per annum, compounded monthly for the thereafter for 4 years. Okay, then determine the amount of money Paul will receive after the investment period. Okay, let me just read this. Paul invested 10,000 into an account which pays 13% per annum, compounded half-yearly for the first 3 years. But for the first 3 years, the account is paying 13,000 per annum, then 17% per annum compounded monthly thereafter for 4 years. All right. In other words, we are going to have a timeline here, whereby for the first 3 years, this is, let's call this T0, T1, T2, T3. But for the first 3 years, it's paying I is equal to 0.13. Then this is 1, 2, 3. Then for the next 4 years, it is T4, T5, T6, and then T7. So for the next 4 years, it's paying at what? It's 17%, so it's 0.17%. So how do you work it out? And how much did Paul invested 10,000. This is 10,000 that he invested in. So now they say that how much is he going to receive at the end of the investment period? If you check on the investment period, it's 7 years. So how do you calculate it? It's very easy. You're just going to say, we know that it's compound interest. You're just going to say your A is equal to 10,000. You grow this 10,000. 1 plus 0.13 compounded half yearly. This is half yearly. half yearly. And then this is compounded. Then 17% compounded monthly. This is compounded monthly. Compounded monthly. All right. So it's half yearly divided by 2. And then how many years are there? It's 3 years times 2. Because it's n, so it's 3 times 2, isn't it? Then this amount of money, this is the amount of money he's going to get here. So here he's going to have this amount. Yeah, he's going to get this amount. So this amount is going to grow again, but a different what? Interest rate, 0.17 whole to the power of 12, because it's compounded monthly, so it's 12 times 1, 2, 3, 4 for 4 years. That's how you do it. Then from then you use a calculator. You're gonna say 10,000. Say 1 plus 10,000, 1 plus to the power of, then you see 1 plus, then at the end let me check here. Yes, will be multiplied by 1 plus is going to be 664 and 58 cents. So this is the amount of money that he's going to receive after 7 years of investment. All right, we need to look at another example whereby it's change of interest rate. For example, Tabo invested, maybe let's say 230,000 into an account which pays which pays 11% per annum, compounded quarterly for the first 5 years, and and 15% per annum, compounded half yearly thereafter. For 2 years. Determine the amount of money Tabo will receive after the investment period. After the investment period, all right, it's easy. First of all, you draw a timeline whereby this is T0. So when it's T0, this is 230,000, which is injected into the account for 11 years, for 5 years. So it's T1, or let me just say for 5 years, this is T5. Then at what? At 0.11. Then for 2 years, it is T7. Let's say the T is T7. Or let me say maybe for 4 years. I don't want the period of investment to be 7. I just want to change it so that's different from the first example. So it's for 4 years. So this is for 4 years. It is T5. So it's T9. So this is 0.15. So when you're calculating the amount of money that Tabo will receive, you're going to say A is equal to 230, 1, 2, 3, 1 plus 0.11. It's compounded quarterly over 4. So 4 for 5 years times 5. Then you multiply by 1 plus 0.15. This is for 4 years. It's compounded half yearly. So it's 2 times 4. Because it's compounded half yearly. This one is, let's say it's compounded half yearly. So it's divided by 2. So it's 2 times 4. Because it's 4 years. Then you're supposed to just punch these figures into your calculator. 230, 1, 2, 3, 1 plus 0.11 over 4 to the power of 20. Then you say 1 plus 0.15 over 2 to the power of 2 times 1. Then you get 705,000. Then A is going to be 705,000. 719 and 57 cents. So this is the total amount after the investment.